Hello, everyone, and welcome to the WGO Climate Course for Global Gastroenterology. I'm Desmond Leddin, the director of the course and chair of this morning's session. As we begin, I'd like to introduce you to the steering committee. Jim, could you share that slide with us, please? I'd like to introduce you to Professor Guilherme Macedo, who's the current president of the WGO, to Professor Geoffrey Metz, who's the incoming president, to my colleague Bisher Omri in the United States, to Mei-Ling Perman in Fiji, and to Dr. Andrew Veach in the United Kingdom. And this is the steering group who have been putting together the course for the last several months. I'd also like to acknowledge today that this is International Women's Day, a group for whom climate change, of course, has particular significance. We will begin with introductions from Professor Macedo and Professor Geoffrey Metz, and then I will come back to take you through today's session.
Message for the World Gastroenterology course on climate change effects in digestive health from the United Nations Secretary General Antonio Guterres. Climate change impacts every aspect of our lives and health, including digestive health. Droughts, floods, and other extreme weather events lead to diminished food production, decreased food quality and safety, and higher prices, raising the likelihood for people to turn to processed and less nutritious foods. Warmer temperatures create ideal conditions for the growth of bacteria and foodborne pathogens that cause food poisoning, and changes in rainfall patterns and water quality can increase the likelihood of waterborne illnesses such as cholera. Climate change and air pollution can also lead to an increase in chronic diseases and infections. We must strengthen the resilience of food systems through sustainable agricultural methods and nature-based solutions. We must also work to ensure clean water and air, promote healthy and diverse diets, and improve access to nutritious foods. By taking decisive action to tackle the climate crisis, we can help to protect the health of people and planet and ensure a more sustainable future for all. Mr. Chairman, dear moderators, friends, and colleagues from this amazing blue planet, I would like to welcome you to the World Gastroenterology Organization Climate Course for Global Gastroenterology. This is an extraordinary and evolving new chapter for those dedicated and concerned with digestive health. We believe that our faculty has created an outstanding program to keep you motivated, alert, and tuned in. Climate change is a tangible, present, and ominous threat to both public and health, in particular digestive health. Global warming has elicited global warnings, either from the emergency of international movements inspired by youngsters or from a multitude of scientists, researchers, doctors, demanding immediate attention over the waste and emissions we generate. When the world was recently brought to a standstill, especially in the beginning of the pandemic, we all witnessed its subtle and notorious changes in our close environment. We realized simply that without human influence, nature looked different, looked like nature. We realized that even without stopping our daily lives, we could change our behavior and allow nature to recover. It was the serendipity of an unexpected pandemic side effect. Digestive health is vulnerable to climate change in a number of ways, and these challenges are even more pronounced in developing world countries. Nutrition, malnutrition, and food security come immediately in our mind. Access to clean water, the issues of contaminated water as a source of infections, and even chemical contamination that may affect water supplies. Population growth, demography, and migration will be affected by climate change. New favorable conditions for emerging infectious diseases derived from altered habitats due to temperature rise. So the time has come to have insight in depth of what we can do. Let us create a proper environment, literally, to understand, educate, and advocate to induce change. This is what will follow over the next sessions in the coming months. We will discuss the roadblocks from financial, systemic, and psychological barriers that pave the way between a concerned awareness to taking some actions. It is widely acknowledged the impact that climate crisis has been having in human life, flora, fauna, and habitat. Provocatively, the delivery of healthcare has been contributing in several ways to increase the emission of greenhouse gases on the planet. The need of breaking this cycle, the need of understanding and identifying the unknown factors of this highly complex equation, and the need of promoting efficient changes in our behavior to tackle the current problems are being recognized by the global gastroenterology community. This has been seen either at the level of national GI societies that have started climate-focused committees or task forces, or through individual members that enlighten and try to promote in many different areas of the world both the awareness and the urgent demanding several implementable measures to directly address the carbon footprint and waste-related challenges. Global GI leadership is truly and deeply concerned about climate change. We need to provide a critical role in educating our members from our societies, leading by example, reducing the environmental impact of our daily procedures, increasing advocacy for solutions and related research funding, informing and supporting politicians to build with us a compelling narrative and a framework of actions leading to change. WGO is in a unique position to provide to the GI community the rules of engagement towards a prompt, global, comprehensive and coordinated action to effectively respond to the climate crisis. We have to face the future with optimism. It is in our hands to do so.
Good morning. My name is Geoffrey Metz and I'm President-elect of the World Gastroenterology Organisation and Chairman of the WGO Climate Change Working Group. And I'd like to add my welcome to you all to this webinar. Soon after the start of the Industrial Revolution, it became clear to climate scientists that increased human activity would cause global warming, and they predicted that global warming would cause dramatic changes to climatic events and to the climate generally. It has taken nearly 200 years for health experts to understand the massive impact these climate events are having on health generally and on gastrointestinal health in particular. Last year, we surveyed the presidents of the 117 WGO member societies, including over 66,000 members, about their views on climate change. The results showed that while 86% of respondents believed that climate change is a crisis, and a majority believed that we should be doing something about it, fewer than 10% have a climate working group or action plan in their society in relation to climate change, and they explained the major reason for their inactivity on a lack of awareness and knowledge of what can be done. The presidents were open to a variety of options regarding improving knowledge, awareness and delivery of education on the issue. It became apparent to our WGO leadership that there is a clear need for our organisation to assist our member societies to raise awareness and to educate their members about the reality of climate change, the impact of climate change on health, and practical changes we all can and should be making to reduce the impact of climate change on health. This webinar series over the next 18 weeks is the first of many actions that WGO is initiating to achieve that outcome. Thank you very much for your attention.
Thank you, Geoffrey and Guilherme, for that introduction and for the welcome. I hope you can all see my slides clearly here. I'm going to take you through a couple of housekeeping things, if I might. First of all, the talk's format and speakers. We have 9 sessions over the next several months, and the topics are shown here. We'll cover today the basics and the impact on health. Next 2 weeks from now, we'll go to digestive health and liver care, then to food, water security, nutrition, children, vulnerable populations. The fourth session, which 8 weeks from now, adaptation and resilience, an industry perspective, and down to the final session at the end of June, where we will ask the head of sustainability for the United Kingdom National Health Service to talk on what they've done. And finally, Dr. Omri will talk about education and research. We will send you a short evaluation at the end of each session, and I hope you will fill that in for us. CME credits are being organized, and we hope to provide an attendance certificate for people who attend 5 or more of the live sessions. The materials will be archived and put on the WGO website. So if you or your friends wish to see them again, perhaps in a time zone that's more favorable for you, you will be able to access those on the WGO site. And finally, there is an interactive question and answer session at the end of each presentation. So I hope you will get your questions together and pop those into the chat box early so that the moderators can begin to collate them. So you've met me, I'm Desmond Leddin. I'd like to introduce you now to today's moderators, Professor Kaichun and Swapna Gayam, and our speaker, one of our speakers, Hugh Montgomery. He'll give the second talk, I'll give the first one. So Kaichun, my colleague, friend, is a member of the WGO Executive Committee, as well as the WGO Foundation Chair. He trained in research in Oxford and Northwestern University. He's got an extensive publication list and is particularly distinguished for his work in gastric cancer. He's Deputy Chair of Qing Hospital of Digestive Disease in Xi'an in China. Kaichun, I hope I pronounced that correctly. And our second moderator is Professor Swapna Gayam. She's Associate Professor at the West Virginia University School of Medicine. Swapna has been a major force in changing the attitude and approach to climate in the United States and globally. She has written and presented extensively on the contribution of GI and endoscopy towards climate change, and she's a co-author of the US GI Multi-Society Strategic Plan on Environmental Sustainability. Our second speaker today, I'm the first one, is Professor Hugh Montgomery, and he is Professor of Intensive Care Medicine, University College London, where he also directs the Centre for Human Health Performance. 22-year track record in the field of environment and health. He's chaired the last 2 Lancet commissions on human health and climate change. He's written and lectured extensively. He now co-chairs the 27-country 35 Institute International Countdown on Climate Change, which reports annually. He's appointed London leader by London's Sustainable Development Committee, attended many of the international COP meetings, and created the Children's Climate Education Project Genie, which I'd recommend to you. It's a very interesting webpage. You should perhaps consider going to look at that. He organized the Royal College of Physicians' first meeting on climate and health, was a founder member of the UK Climate and Health Alliance, and helped create the International Alliance on the same subject. He organized the first international meeting on climate, health and security in 2009. So I'm sure you will welcome him. Jim, I'm going to stop sharing, and if you would like to put up the first talk, which is from me, on the basics, that would be great. Hello and welcome to this talk on climate change, the basics. I'm Desmond Leddin, Professor of Medicine at Dalhousie University in Canada. The objectives which I'd like to cover with you are shown here. First of all, to go over the terminology, the language of climate change. Then to talk about what are greenhouse gases, where do they come from, how do they raise atmospheric temperature, how does a change in temperature affect climate, access to water, shelter and nutrition, and touch on the linkage between biodiversity loss and pollution. Some of the terms which are used are shown here. Carbon footprint and carbon dioxide equivalence are important to understand. Carbon footprint is the total amount of greenhouse gases that are generated by our actions. So, for example, when we fly someplace or drive a car, that produces greenhouse gas emissions which can be measured and expressed as our carbon footprint. And a carbon footprint can be described either for an individual or for a whole country, or indeed for the whole planet. CO2 equivalence is often used because Carbon dioxide is the most common greenhouse gas, and although there are many greenhouse gases, they can be related back to CO2 equivalents. Global warming and global mean surface temperature you'll hear about a lot. This is an important term to understand. Global mean surface temperature refers to the average change in temperature for the whole planet, and that includes oceans and land surface area. A particular region may experience a rise in temperature which is much higher or indeed lower than the global average, so it's important to understand that. Greenhouse gases and warming potentials we'll discuss in some detail. And just to mention to you that two of the foundational structures underpinning the whole climate change action are the United Nations Framework Convention on Climate Change, which is a treaty signed in 1992, and the Intergovernmental Panel on Climate Change, the IPCC, which is the main scientific body which collates the literature and produces regular reports on the state of the climate and on our actions to address the challenge. You will hear tons of CO2 being mentioned frequently. Current global production is about 50 billion tons of carbon dioxide equivalents per year, and that equates to an average per capita of about 6 tons per person per year on the planet. It varies a lot by country. Canada, where I live, has an average per capita emission of about 14.3 tons per person per year, but the Democratic Republic of the Congo only has 0.03. And this is one of the injustices of the whole climate change crisis, that many countries which have contributed least to the problem will be the ones which may be expected to suffer the most. It's hard to imagine what a ton looks like, and maybe the best way to do it is to imagine a cube that has dimensions of 8 meters by 8 meters by 8 meters. The volume of gas contained in that cube is equivalent to a ton of carbon dioxide. It's roughly the size of a small house. So a cube of that size will have over 500,000 liters of carbon dioxide in it. So when you fly someplace and you measure your emissions, you estimate them in tons, it may help you to visualize that cube as the contribution that the action is actually making. The greenhouse effect occurs because radiation comes in from the sun in shortwave, gets through the atmosphere, warms the surface of the earth and the oceans, changes from a shortwave wavelength to infrared, and much of that is reflected back into space. But the atmosphere is able to hold some of that radiated infrared energy in, prevent it from getting back into space, and keep the Earth warm. That's a good thing. If it wasn't for our atmosphere, our global mean surface temperature would be about -10, -12 degrees centigrade. So the atmosphere is beneficial. The problem is that the greenhouse gases are trapping too much heat in the atmosphere, and it's leading to progressive warming of the atmosphere which surrounds the Earth. The way that they do that is shown here. Carbon dioxide, because of its molecular structure, or water, are able to trap infrared radiated energy. And they do that by increasing their own kinetic energy, and they hold that energy in the atmosphere and lead to progressive warming. The distribution of warming on the planet is not uniform. So, as I mentioned earlier, when people talk about a global mean surface temperature warming of 1 degree or 1.5 degree or 2 degrees, you might think that it's the same every place, but it isn't. And as this map shows, this is a distribution of heat at global mean surface temperature warming of 1.5 degrees centigrade. You can see that the northern latitudes, particularly the Arctic, are warming to a much greater degree than some of the other areas on the planet. Greater warming is also seen through much of Europe, the Mediterranean basin, down through Saudi Arabia and the near Middle East, and also in some parts of South America. The oceans, conversely, are not warming as much because of their ability to buffer heat, at least in the short term. This change in global mean surface warming leads to changes in the pattern and distribution of wind and rainfall and other climate issues which are so vital to human existence. So this map, which is from the Intergovernmental Panel on Climate Change, the Interactive Atlas, which I'd strongly recommend to you, shows changes in consecutive dry days at warming of 2 degrees centigrade. The bluer areas are wetter and the greener areas are drier. The hatched areas are where the data is still uncertain. And I've picked just one parameter here, but you can go into this interactive atlas and pick up to 30 or more parameters, and you can look at that for your local region. So here we're looking at consecutive dry days. And so what you can see very clearly is the projection is for an increase in consecutive dry days in southwestern United States, Central America, East South America, west coast of South America, and that will extend into the Mediterranean basin, into the near Middle East, and right over to China, down to South America, Indonesia and the islands, and of course Australia. So all of those areas are expected to see a decrease in precipitation and an increase in consecutive dry days. So it's not uniform. Some parts will actually experience an increase in rainfall. Parts of Africa and parts of India and Bangladesh may experience that change, but it is not uniform. And these changes in distribution of rainfall, which are so important for access to clean water and for our ability to grow crops, have really profound implications for human migration and sustainability in different parts of the world. Why is this happening? Well, to understand that, we've got to go back a bit. And on the x-axis here, we have years from the current date back to 10,000 BCE. And on the y-axis, we have the population of the Earth from 0.5 billion up to 8 billion. So about 12,000 years ago, there were only 4 million humans. But 3 things changed then. The first is the last ice age ended. The second is we discovered agriculture. And the third is the climate went into a period of stability called the Holocene period of climate stability. And that allowed us as humans to flourish from near extinction, so that by year 0, there were about 200 million of us. That rapidly increased so that by 1800, we reached 1 billion. And once we reached that critical mass and unleashed the power of fossil fuels, our population numbers took off very rapidly indeed. And you can see the rise here from 1 billion to 5 to 6 and up to 8 billion now. The problem is that the planet cannot sustain this number of people at our current level of consumption and utilization of fossil fuels. And that is the difficulty that we're in. The greenhouse gases are shown here. Carbon dioxide is the most common one. It originates from fossil fuels and extraction and usage, and from biological processes. Concrete production will also produce quite a lot of carbon dioxide. Because it's the most common gas, it's given a global warming potential, a WP of 1. Methane occurs from the production of coal, natural gas and oil. Livestock, cattle release it, as does land use and decay of organic materials. It comprises about 16% of greenhouse gases, but it is much more potent than carbon dioxide with a warming potential of 28. And then we have nitrous oxide, another main gas, about 6% of that. Agriculture, industrial activities, combustion and wastewater treatment, and it is very powerful with a warming potential 265 times that of carbon dioxide. The fluorinated gases, which are used in industry and healthcare, are not so common, about 2%, but they're hugely powerful, 15,000 times more powerful than carbon dioxide. And as I mentioned earlier, water vapor is a naturally occurring greenhouse gas, which is why you notice a difference in temperature on nights when there's no cloud cover. So total greenhouse gases emissions in 2019, as I mentioned, is currently about 1 billion tons a week. And this shows a global map of which countries are producing most. The darker the color, the more greenhouse gases are being produced. And you can see that the greatest producers are the United States and China, followed by the darker colors, Canada, Brazil, many of the countries in South America. Many of the countries in Africa are not producing much in the way of greenhouse gases at all, although they stand to be very significantly impacted by climate change. And then Russia, the Arabian Peninsula, of course, India, not because it's producing so much per person, as because there are so many people, the cumulative production is very high. And of course, Australia as well is a significant contributor to global production. So we have to work together internationally in order to reduce gases. This is a global problem. It's a problem which we all share and one which we all have to work together collectively to address. What about the relationship between climate pollution and biodiversity loss? Well, when we burn fossil fuels, for example, in our cars, it produces particulate pollution, particularly PM2.5, which are injurious to human health. And some of the activities which we do, such as cutting rainforests to produce grazing land for cattle, destroys biodiversity. The cattle then produce methane and nitrogen waste, which pollutes rivers and which damages the climate. So there's a very close linkage between climate change, pollution, and biodiversity loss. The three are linked and they tend to travel together and need to be regarded really as a unit. What are the consequences of warming? Well, we already touched on some of the consequences. Changes in wind, rainfall, and temperature will make some parts of the Earth uninhabitable, but there are also very significant consequences for health. This is taken from the Chief Public Health Officer of Canada's report on the state of public health, and they summarize it as here, that the drivers of climate change are unsustainable growth. We've been living beyond the planet's means. That unsustainable growth and exploitation of fossil fuels is leading to changes in the atmosphere. As we discussed, changes in the atmosphere is leading to changes in climate and the weather which we experience in terms of temperature, rain, wind, seasons, storms. The change in climate in turn is producing climate hazards, extreme weather, difficulty accessing food and water, ability to access clean air, and slow onset events like droughts and glacier melting. And that in turn, that climate hazards are resulting in adverse health outcomes. And there are signals now for virtually every health system being adversely affected by climate change. So it affects mental health, it affects infrastructure and our ability to deliver care. There are direct effects of heat and our ability to work outdoors. Significant reports of increased cardiovascular morbidity, changes in prenatal and pregnancy care, respiratory disease, infectious disease patterns changing, digestive health, which you'll hear a lot about in this course, poverty, of course, because people are plunged into poverty as change in their circumstances, and forced migration between countries and from rural areas to cities. So all of these outcomes are related to our behavior and to the changes which we're producing in the atmosphere. And it's all compounded by socioeconomic status, social determinants of health, age, and geography. So where do we go from here? And you're going to hear a fair bit about this over the course of the next few weeks. Well, we still have ability to change the trajectory. On the x-axis, we have years from 1990 up to 2100, and in the y-axis, we have greenhouse gas production from 0 to 150 gigatons. And as I mentioned, we're currently producing about 50 gigatons of greenhouse gases per year. And here we are at 2020, 2023. In order to hold global warming to 1.5 degrees, we need immediate and sustained reductions in greenhouse gas emissions. Immediate. There is no more time to delay on this, and the longer we delay, the greater the reductions will need to be. If we continue on our present trajectory with no climate policies, it is projected that global mean surface temperature may reach between 4.1 and 4.8 degrees centigrade by the end of the century. And that is, without exaggeration, an existential threat to human survival. Current policies are likely to get us to between 2.5 and 2.9 degrees centigrade, and that is going to be a very difficult obstacle to overcome. It will have profound implications for our survival and for how we live on the Earth. So we really need to move quickly to reduce climate change and to reduce emissions and get this situation under control. So what did we cover in the last few minutes? Well, we talked about the terminology, the language of climate change. We talked about what are greenhouse gases, where they come from, how they raise atmospheric temperature, and how it translates into changes in access to water and nutrition. And finally, a little bit about biodiversity loss and pollution. I'd like to thank you very much for dialing into this talk. I hope it's been of use to you, and I look forward to any questions which you might have. I hope you'll join us for the rest of this course right from now through to the end of June, and you will hear some outstanding speakers during this event, and I'm sure it will be of use to you. Thank you very much for joining me.
Well, hello, my name's Hugh Montgomery. I'm Professor of Intensive Care Medicine at University College London, where I also co-chair the Lancet Countdown on Health and Climate Change. And if I move myself out of the way there, I'm going to tell you about written warnings. You're familiar with these on food packaging, of course, and a lot of people ignore them. And we've been ignoring warnings for a very long time too. The first of these warnings came in 1859 when John Tyndall warned us that the combustion of fossil fuels released greenhouse gases such as CO2, and these let shortwave radiation through, but trapped longwave radiation or heat. And he said that this was a threat to our survival. And he was right, but we ignored that warning. The Conference of the Party negotiations there started in 1995, and they've been warning us too, saying we have to peak emissions very soon, and they've said that every year. But we've ignored those warnings as well. The net result meaning that carbon dioxide concentrations in our atmosphere, along with other greenhouse gases, continue to rise inexorably. That traps heat. It's trapped in our gaseous atmosphere, the equivalent to 6.7 billion Hiroshima bombs worth of energy since 1950, and we're currently trapping around the equivalent of 8.7 Hiroshima bombs of energy every second. That's over 274 million more every single year. Global temperatures as a consequence are rising, and we're melting Arctic sea ice. We're also seeing that the summer sea ice extent falling steeply in Antarctica as well. The Greenland ice shelf is melting, losing around 1.1 million metric tons of fresh water every single minute. And that water, added to thermal expansion of the oceans, is causing sea levels to rise, now by around 1 centimetre every 2 years. If you add energy to an atmosphere, you get extreme weather, or you get weather. And the more energy you add, the more extreme the weather events are, and the more often there will be. And if you look at the most extreme weather events we've had in the last decade or so, you'll see some of them we can be certain aren't caused by us, some we don't know. But the vast majority there in red, we now know, are due to human-induced climate change. And you're familiar with that. This is no surprise to you. You'll remember the fires in Eastern Australia in the Northern Hemisphere winter of 2019. But they weren't alone, were they? Siberia has been ablaze right way through the last few years. California as well. The Amazon rainforests, 3 times as many fires in the rainforests of Angola and Congo. Bottom left there, Indonesia. Canada, do you remember, in the summer of 2021? Remember that same summer, the whole of Europe ablaze. Colorado at the end of that year. Heat waves too, of course, moving forward into 2022. Record temperatures in South America and Australia in the January. Record temperatures in the spring in Pakistan. Record temperatures in China as we move into June. Then later in June, Japan and Korea reaching record temperatures too. And then Britain and the whole of Europe being hit as well with record temperatures there. And not just there, but Lake Mead, for instance, as shown here, in the United States of America. So this was global, but it wasn't just heat waves and it wasn't just fires. It was floods on the Belgian-German border in the summer of 2021, in Germany itself, in London, in China with tens of thousands dead, and in the New York subway. We saw flooding later that year in British Columbia and just before Christmas in Malaysia, displacing upwards of 71,000 people, and in Australia. We saw at the beginning of last year the highest density rainfall ever recorded in South Africa, the same in Valencia in Spain. Later in the year, a third of Pakistan was underwater, record storm surges in Florida, and then record flooding in Venezuela, and over 500,000 displaced in Nigeria in the autumn of last year. Then we moved through to the winter, of course, the sudden freeze in North America with images such as this, while in Europe, record temperatures on January the 1st, Bilbao 25 Celsius against a normal of 10 Celsius, and record temperatures in 8 other countries. The point being that with a global surface temperature average rise of 1 and a bit degrees, this is desperately unsafe because it's not about the temperature rise itself, it's about the energy gain. And we're seeing it rolling on with California in January of this year. We're heading, though, not just for 1 and a bit degrees, because a third of the greenhouse gases, or a fifth of the greenhouse gases we emit today, still cook our planet in 33,000 years' time, and 7% in 100 years. So we're looking at rises towards 5.5 degrees by the end of the century. And indeed, with sustained emissions, we know looking at temperature rises towards 10 Celsius. This will be the end of human life as we know it, and end of our ecosystems as we know them too. Because even if we draw down greenhouse gases now for our atmosphere, climate change we're locked into because of that long half-life for thousands of years. But the hit is already with us, and the hit is going to get rapidly worse. The IPCC saying that species extinction, widespread disease, unlivable heat, ecosystem collapse, and cities menaced by rising seas will become painfully obvious before a child born today turns 30. So that's in your lifetime and all that of your children. And if you want them to live and you wish to live, you must act. We know the impacts will be terrible. 18% of the world's surface area currently occupied by humans will soon become uninhabitable. 2/3 of a billion will have to move as a result of sea level rise, displacing potentially half the world's population. That's 4 billion people there before we even consider extreme weather events. But it's worse than that because emissions are not going up linearly, they're going up exponentially. And we've triggered 9 positive feedback loops. The fires, for instance, in Australia, releasing carbon dioxide, which traps more heat, which causes more fires. But it also releases carbon monoxide, which mops up hydroxyl radicals, which would normally clear methane. Methane, 83 times as powerful a greenhouse gas as is carbon dioxide. The loss of surface albedo is important. That's the reflection of light back into space from ice and snow. If you melt ice and snow, there's more dark soil and ocean to absorb it. And as a result of that, we've doubled energy gain in the last 14 years. At the same time as we're releasing methane from carbonate rocks, from melting methane hydrates in tundra, and also from fermenting wetlands. Meanwhile, if you blanket an area with smoke, it drives up surface temperatures, causing more fires. And in fact, the blanket of insulating smoke in Australia and those fires in 2019 raised Australia's average surface temperature by 3 Celsius and the lower stratospheric temperature by 0.7 Celsius due to black carbon absorbing heat. They also punched a hole in the Antarctic ozone layer. Meanwhile, rainforests are catching fire progressively. We're losing 16 soccer pitches a minute to fire, and that's reducing the area, meaning that the greenhouse gas emissions are going up. And in fact, the major rainforests of the world, all 6 of them, are now net CO2 emitters. But it's worse than that too, because weather states will change in a binary fashion. The poles, the Antarctic and Arctic, are warming 3 times the rate of the global surface average, and that can accelerate dramatically in what are known as Dansgaard-Oeschger events. And here's one around 38,000 years ago in the middle there, where temperatures rose by 10 or 12 Celsius in a matter of only a decade or two. To the far right, you'll see this paper in Nature is predicting that we've triggered one of those, and the evidence would say that we have, because if you look at March 21st of last year, Antarctic temperatures were 40 Celsius above normal, and those in the Arctic 30 Celsius above normal. It was worse the next day, though, on the 22nd, when Arctic and Antarctic temperatures were fully 47 Celsius above normal. In June of last year, average temperatures inside the Arctic Circle were fully 32.5 degrees Celsius against a normal Arctic summer average of only 13 degrees Celsius. And we're seeing this instability. This is Greenland with a sudden rise in temperature on the weekend of the 2nd, 3rd of September, a rise in temperature of 20 Celsius, producing melt across a third of the Greenland ice cap. On the 3rd of September alone, this much water was lost. And over that one weekend, 20 billion tons of fresh water melted. That's 7% of the total annual melt for that year in one weekend. And that would be bad enough, were it not that this was the second year in a row that this has happened, with rain on the summit of the Greenland ice cap, 2 miles above sea level. We're seeing disruption, or will do, in global movements of this, particularly the oceans. The Atlantic Meridional Overturn circulation, they're drawing in warm water from the Pacific, coming up past us, top left in Britain there, as the Gulf Stream. If that changes, there's going to be major disruption to global weather systems. And we now know that we're at a point close to critical transition. When? Same as before, really, and for the southern meridional overturn circulation, sometime in the next few decades. The jet stream is also moving. This is a high-velocity river of very moist air between the cold Arctic air and warmer air to its south. That's progressively moving north, but also being unstable. When that happens, there's going to be no significant rainfall left to support crops in the Iberian Peninsula. That's Portugal and Spain. And that rain is largely going to fall on Northern Europe, where we'll get very much heavier flooding and rainfall in the winter, again, disrupting crop production. We're seeing the same, though, with the changes in the jet stream, which has bifurcated now twice and split, trapping hot air between its split, giving us this ring of fire we had around the globe last year with these extreme temperatures. And we can expect this to becoming much more frequent. And it's not just, though, the atmospheric scientists and climate change scientists that have been warning about these impacts. The Pentagon in 2003 warned that without action on climate change, the result could be, quote, a significant drop in the human carrying capacity of the Earth's environment. They too were warning about billions dying in the coming few decades. So to the World Economic Forum, which, when it asked its members the greatest threats to on a global scale of the next decade, in at number 1, climate action failure with extreme weather event, biodiversity loss, human environmental damage, natural resource crises, and consequent geoeconomic confrontation. And we're beginning to see these impacts economically appearing. They were right. This was the Po River, which normally supplies 22% of Italian agriculture. With the heat and with the loss of that water, there was a huge impact. Grain production down by up to 40%, fruit and milk down by 20%, and a loss of around 3.8 billion euros to the Italian economy. French corn production was reduced. Crops failed in China. Massive impacts on the crop yields in India as well. We saw the entire barley crop in Syria collapse last year, and we've seen essentially famine in the Horn of Africa as a consequence. Power production was badly hit. There's the Po River at the top. Normally around 20% of Italian power production is renewable, and half of that comes from the Po River, and that was badly impacted by the droughts of last summer. In France, a lot of power, 70%, is from nuclear reactors which need cooling. And where there is insufficient water or the water is too hot, you have to scale those nuclear power plants down or switch them off. And the same in Sichuan in China. Hydroelectricity, they're a major player in power production, and that fell by 50% last August, just when energy requirements were so huge due to air conditioning demands. Gas transmission pipelines got ever hotter. That meant that the pressure rose, which meant you could transmit less gas in them. And solar panels become less efficient by around 25% in the heat, again, impacting on power generation. There were other economic impacts too, though. This was the Rhine, which on the 18th of July dropped to 36 centimetres at Calbe, meaning that for every 1 barge that would normally get through, you now needed 4 for a shallower draft, putting up the costs of goods transmission. And we saw the same in China, 66 rivers across 34 counties just in the southwest, drying up in August last year. So this is your call to arms. We cannot sit idly by if we wish to live and if we love our children, because politicians will not fix this. This is the atmospheric CO2 concentration from 1960 with some of the major climate negotiations, and nothing there has happened. And if I move myself just out of the way there, these are the last 27 COP negotiations, which have had no impact at all. In fact, the rate of rise in greenhouse gas emissions is going up. We were told that to stay below 1.5 degrees, which is still catastrophic, look at what we've got at 1.1 degrees, we'd need to reduce emissions by nearly 50% by 2030. The IPCC warned that any further delay in concerted global action would mean we missed a brief and rapidly closing window to secure a livable future. A livable future, one in which you and your children might survive. But it's worse than that, because we now know we've got over a 25% chance that we're going to punch through 1.5 degrees even next year. What are politicians doing about it? Nothing. This was the end of the last COP negotiations, Secretary General saying we need to drastically reduce emissions now. And this is an issue this COP did not address. Well, forgive me, but you and I might have thought that was the purpose of these negotiations. So you need to take action now, personal action. So write these things down, do them now, or do them this evening. If you have a choice in your bank, move it to one that does not invest in fossil fuels. In the United Kingdom, that, for instance, would be the Cooperative or Triodos Bank. Change what you buy. Buy less, number one. We just don't need all this stuff. Buy second-hand where you can. Reuse and repair what you can. And if you need to buy new, buy from companies only that have made a really big commitment to reduce their impact on the environment. Move your energy supplier where you can. In Britain, there's a lot of greenwashing, but there are companies that supply 100% renewable power, such as Octopus or Good Energy. Put solar panels on your roof if you can afford them and if that's suitable for where you live, or other energy generating sorts of technology. Insulate your house, wear more clothes in the winter if you need to, turn your heating down if you heat your house. Every degree is 7 to 11% emission reduction. Engage others to act. Think about where your savings are and make sure you are not investing in fossil fuel companies. You must get out of that right now. And in terms of sustenance, which is, of course, mainly what your meeting's about, agriculture has a very important role here. Cows belch methane, 83 times as powerful a greenhouse gas as carbon dioxide in its first 20 years, but pasteurization of dairy and refrigeration of these products makes dairy and ruminant meat very high in their greenhouse gas emissions. They're also unhealthy, and we need a diet that is much more based on local, seasonable, and vegetable-based products. So make that move for yourself. Think about your travel, so walk and cycle. Use public transport if you can't do that. Use mass transport together, share cars, for instance, if you can't use public transport, and please try not to fly. Vote politically. Let your candidates know that you will be voting on this as a singular issue, and vote with your money where you spend. And finally, we need to move our healthcare. 5% of emissions come from healthcare, but we're responsible for around 12.7% of global domestic product. So if we change how we spend money, we can make a huge difference to cash flow globally. We need to get our hospitals and healthcare facilities to move immediately to 100% renewable power, or to get power purchase agreements for 100% renewable power. We need to move the diet of our patients and staff to local, seasonal, vegetable-based products with less reliance on dairy and ruminant meat. We need to do less. An awful lot of what we do in healthcare actually doesn't make any difference. So let's make our pathways lean, do fewer tests, and do fewer things that actually just don't help people. Let's critique those. And we need to change our procurement globally. So club together with other healthcare institutions and say, from 2025, we will not be buying from anyone who has not committed to reduce their scope 1 to 3 emissions by fully 50%. Remember, there is no such thing as net zero. There is only real zero. Net is a con. So in summary, we are in terrible trouble. If you wish to live and if you have children and love them, you have to act, and you have to act now. You cannot rely on anyone else doing this. And if you do, you will not be the villain of the piece bearing the guilt. But instead, as David Barry said, we could be the heroes forever and ever. What do you say? Thanks very much indeed for listening.
Thank you, Professor Montgomery, for that talk. And I'm now going to hand over to our moderators, Professor Wu and Professor Gayam, for a somewhat truncated discussion period, because it's the first session we had to do introductions and housekeeping. Kaichun and Swapna, over to you.
Good morning. That was an excellent session. Amazing talks by both Dr. Leddin and Dr. Montgomery. After listening to Dr. Montgomery's lecture, I'm kind of down in the dumps because it just looks gloomy. What do you think? Does anybody think there's any bright spots to it? I mean, what can we look forward to? How can we give people hope?
Bisher, why don't you take that?
Thanks. Well, first, Des, Professor Leddin, thank you so much for organizing this terrific talks. So I think what part of it is education, and hopefully this is one of the goals of this course, because certainly when I talk to friends, family members, and so on, I don't think there's a grasp of what the consequences like Dr. Montgomery had just outlined. I think that is not appreciated. And maybe that small thing, which is actually challenging to get the word out, can make a huge difference, because we as individuals can in fact do a lot.
Yeah, I completely agree. Now, I do have another question. So we always are told, by societies, by our hospitals, give us the low-hanging fruit when we're trying to propose these, measures to go eco-friendly and go green. Do you guys think there is time to start slow like that, to start at the low-hanging fruit level? Or do you think it's time for like big institutional changes and big governmental policy changes? And kind of go big right now, because from Dr. Montgomery's lecture or talk, that's what I kind of gather. And we all know that we can do big changes fast, that the lessons that we learned from our recent COVID pandemic. So what do you guys think about that?
Guilherme, why don't you come in on this one, would you?
Yes, sure, and great. It was a great start, by the way. We don't like the fear factor, but in fact, it's really important to raise the awareness of all this and make people understand and realize what's happening in the world. And what we're going to see in the next months is that the way that we are dealing with and the way that we are proposing to change things. So I think that at this time, of course, to make a real change, politicians must be on board because they make the political decisions by definition. But the only way that the politics understand what we are doing is because they rely on our votes. So they rely on votes from the public. So if we raise the awareness of the public, especially because doctors are still very important for everyone. So I think we should be partners in that type of decisions and in that part of, in those moments, special moments of getting the notion and the consciousness about this problem. As soon as you get to the politicians, as soon as the politicians understand that this is really a problem, and the doctors are engaged in solving this, perhaps we can make the difference. Never forget that politicians are just like kings used to say, just to have a wording of music, like Bowie said, give people what they want. So we really need to understand that this is a real problem and we need to tackle it.
Super, thanks, Guilherme. Maybe, Swapna, we might bring Geoffrey and Mei Ling in to get a view from the Southern Hemisphere.
Thanks very much, Des. Just to add to what Guilherme was saying, Swapna is absolutely right. We have to act ourselves. Our hospitals have to act. Our medical societies in each of our countries have to act. But people power is pretty impressive.
In Australia, a lot of you won't realise, in Australia last year, May the 21st, we had an election. And in that election, one party was saying they didn't believe in the climate change, and the other party was saying climate change was their #1 priority. They were the opposition, but they were swept into power. They are now the government. And so when people understand this, it really can translate into government action. Politicians don't act because they think it's a good idea. As Guilherme said, they act because they want to stay in power and they understand that the people put them there and will keep them there or kick them out. So I think we have to act on all of those points. Thank you.
Super. Thanks, Geoffrey. Mei Ling, are you able to join in? Thank you.
Yeah, wow. Both talks are really amazing and sobering. And, you know, us in the South Pacific, you know, we're facing a lot of these extreme of weather. And, you know, just recently there have been like 2 cyclones happening in Vanuatu just last week. And they were experiencing heavy rain and flash flooding in Fiji. So, you know, even though we probably generally would maybe point fingers and say, okay, we're not contributing too much to this climate change, and yet we're experiencing all these disasters. But really, in the end, everybody must act, you know, all of us. So, you know, it's good to see the message by Professor Montgomery earlier about the best vote. You know, that's equipping ourselves to how to act. So, yeah, I think this is great. Yeah. Thank you.
Thank you, guys.
Swapna, maybe we could get a comment from Kaichun as well. And we are, unfortunately, in this truncated discussion, we're going to run out of time very soon. So I would say to people who are putting questions in the chat box that we'll try and address them on the WGO website. We'll answer those questions. Kaichun.
I just have one last question for you, because we are all gastroenterologists. As a specialty, do you think the gastroenterology is in a more priority of dealing the problem of climate change than the others, such as the cardiology or nephrology or hematology? What it's more important for us to do?
Well, I think traditionally, or at least historically, digestive health and disease hasn't been given the same attention as cardiology and respirology, but I don't think we're in a competition with them. I think there's a signal here for every health system in the body, but we have to make sure that we advocate for the needs of people with digestive health. And certainly issues like nutrition, access to water, access to food, diarrheal illness in children are critically important and a huge cause of morbidity and mortality. Swapna, back to you.
So yes, like you said, you know, we can definitely answer all the questions. We have about 4 questions here. We can answer them on the website. But my question is, when we say competition, maybe it is a good thing to have a competition among, you know, among all the different medical fields. So things are done faster. What do you guys think?
I think we need to cooperate, maybe cooperate and compete, Swapna. So listen, on that note, I'd like to thank you all. We're just coming up to the hour. Jim, if you could show that slide for the next session, please. We'll summarize and sign off. Thank you. So thank you very much, everyone, to the speakers and the moderators and the panels for contributing. I really appreciate it. And thank you especially for joining this and becoming part of what we hope will become a global movement to change how we're delivering care in digestive health and hopefully, as Professor Montgomery said, to move towards solutions. In 2 weeks' time, we're going to have 2 of the world's leading experts on the topic join us, and I hope you'll come back and encourage your friends to join us. We'll have Professor Nicholas Talley from the University of Newcastle in Australia, and Professor Marie Donnelly, who will talk about the implications of climate change for liver disease. And those promise to be outstanding talks And I think we will have more time for interaction at that time. Thank you very much for joining us. With your permission, we'll close it out now, Jim, and we'll see you soon. Thank you and goodbye.
Bye-bye now. Thank you very much.
Bye-bye.
Bye all.